Hi class. So today I am talking about section 10.6 equation involving radical expression. In this session we will talk about um, power rule for solving equation and um, for power rule for solving equation, if x side of an equation is raised to the same positive integer power and solution to the given equation among to the solution to the new equation. So what does that mean? Like if you have square root of 2x equal to x over here, what you do, you're gonna square both side or square each side, and they're gonna be still um, the equivalent equation, um, and then you just gonna uh, solve this equation, but then after you solving it, you have two solutions, but you need to double check this answer to make sure if it's satisfied for the original equation. So later on I'm going to show you um, the step how to apply the power rule for solving equation. Also, we will learn about Pythagorean theorems in this session. With in here, I have like a right triangle, okay, um, and C in here is hypotenuse, and and the A and B gonna be the two legs. So then the formula of the Pythagorean theorem say the square of I mean the square of the addition of square of two legs equal to the square of the hypotenuse. So we mean a square plus b square equal to c square. And for this one, I can apply to find any to find some information about a right triangle if they give us like a two side information, and you can just apply the Pythagorean theorem formula to figure it. Okay, so also we will learn about distance formula in here. We will use the information given from the coordinate of 2 points, and we will try to find the distance between these 2 points by the formula over here. Okay, and lastly, let's move that. Lastly, we will learn about solving equation n is a positive integer. What we do, you're gonna take the nth root of x star, so we can cancel the root index n, and then we will have 2k. For the k that if n is odd, you're gonna right away have only one solution, such as x equal to root n of k. But for the k, if n is even and k is greater than or equal to 0, then you will have two solutions, such as positive and negative of root n of k. Okay, so you can have over here as some example, if if n is odd, you have like x power fifth equal to 32. So we're gonna take fifth root both inside and get x equal to fifth root of 32, which is equal to 2 over here. And for the case of x equal to the case of n is even, so you have like x4 equal to 81, and then x gonna be you're gonna take 4 root both inside, and you're gonna have x equal to positive and negative of root 4 of 81, which is equal to positive and negative number 3. Okay, so let's start to have some problem with solving radical equation in we're gonna apply the power rule in here as a equal to b, so we have a to power n equal to b to power n. The step in order to solving a radical equation, let me use color here. So we have step number 1 is isolate the radical term, and step number 2, you're going to apply power rule by raising x side of the equation to the power equal to the index of the isolate radical term. And step number 3, you're going to solve the equation, and it still contains a radical repeat step 1 and step 2. And last step is if you want to check the answer to make sure the solution is satisfied for the original equation. Okay, so let's start with an example over here. Okay, so I have square root of 2x minus 3, 2x minus 1 equal to 3. And then we want to solve it and then check the solution. So let's start with step 1 is isolate a radical term, right? We in here we did have the radical term has been isolated already, so we can skip step 1, right? Let's say step 1, isolate the radical. Done. So we can just right away go to step 2. So step 2, we're going to apply power rule. So apply power rule for this problem, you're going to square both hand side. So you have square root 2x minus 1. I'm going to square it equal to 3 squared, right? So I'm going to have what? I have 2x minus 1 equal to 9. So step number 3, solve the equation. So how to solve this equation? I'm going to add both inside by 1 to get, then I get 2x equal to 10. And I divide both inside by 2. So I can have x equal to 5. So what I do is right now, when I move to step 4, is check the answer. So I'm going to substitute x equal to 5 into original equation. So I have square root of 2 times 5 minus 1 equal to 3. So then I have square root of 9 equal to 3. And that's equal to, that's 3 equal to, I mean, that is true statement, right? So good. So the solution should be x equal to 5. Okay. And I just gonna circle this. Okay. So let's move to B. Have another example. So B, I have square root of 4 minus x plus 5 equals to 8. So for this one, I need to follow step 1 by isolate the radical term. So step 1, I need to subtract both ends by 5, right? So step 1, and I have square root 4 minus x equal to 3. And minus 175. So okay. So now what I'm gonna do is I'm gonna move to step 2. Apply power rule in here. So I'm gonna square both inside. Okay. Why I do square both inside? Because we are having square root for this radical. So I need to square both inside. Okay, so I may have moved to down to I actually have 4 minus x equals to 9, right? So step 3, I'm going to solve this equation by, subtract 4 by inside. So I'm going to subtract 4 by inside. And then I have negative x equal to negative 5. So I have, negative x equal to 5. So I have x equal to negative 5. Is this a solution? I need to check. Make sure in the radical equation, you always have to check the answer, okay? So check x equal to negative 5 by substitute. So I have square root 4 minus x, now become negative 5, right? Plus 5 equal to 8. So I have square root of 9 plus 5 equal to 8, and that is true statement. So I'm gonna say, so solution is x equal to negative 5, and I'm just gonna circle the answer. Okay, let's move down and do the next example. In this case, problem C, I saw that both ends have an expression with x, right? But in one hand side, I have a radical expression, and then we still have to follow the 4 step to to solve this equation. Now I'm gonna just, I'm just gonna write out it quickly. So for the first step is isolate the radical. I'm done, right? So the second one, I'm gonna square both hand side. So I'm gonna square both hand side because I'm having a square root. So I square both hand side. Yeah. So after square both hand side, I will have the left hand side become 3x plus 3. The right hand side will give me you can consider it as like two, you know what, let me have a sidewalk here. You can consider it as like 2x minus 1 square gonna be equal to 2x minus 1 times 2x minus 1. You can do like that. But if you remember the formula, you're gonna have like a 4x squared minus 4x and plus 1. Okay, so then you're gonna just, plug in and have 4x minus 1 minus 4x plus 1 over here. Okay, so in order to solve, so now we move to step number 3, which is solving this equation. And in order to solve this equation, you need to move everything in one hand side. So I decide to, move, maybe move, move all the right hand side to the left hand, move all the left hand side to the right hand side because I have the right hand side with 4x squared, which is like a leading term with a higher degree. So I decided to stay here, and I move the negative 3, minus 3x plus minus 3 for both inside. Right? So then now you are going to have a new equation as so this is gone. So I have 0, and I have right hand side going to be equal to 4x squared, and then minus 4x minus 3x going to be minus 7x, and then plus 1 minus 3 going to be minus 2. Okay, so for this one, I know this is a quadratic formula, right? I maybe have to make it bigger so I can have sidewalk, right? So if I have A times C, I know that A in here is 4. C in here is negative 2. So A times C gonna be 4 times negative 2, which is negative 8. And I have B in here equal to negative 7. And I'm gonna find two numbers that multiply equal to negative 8 and addition equal to negative 7. So I think it should be let's say 2 and 4, it didn't work, right? Let me see. Let's start with number 1. Say 1 times negative 8. Okay, so 1 times negative 8 will be negative 8. But 1 plus negative 8 will be negative 7. That is good. Okay, so 2 in this number is 35. But remember, in this case, I have A equal to 4, which is not number 1. And that's really not a special case. So what you do is you're going to split this, split the negative 7x to become or x minus 8x. So I'm gonna rewrite it as 0 equal to 4x squared, right? And this -7, now I will rewrite it as 1x, so plus 1x and minus 8x and minus 2, right? I split the middle term become two term because now I have four term and I'm gonna using grouping method to factor this stuff. So let me move down from D here so we have more room. Now let me have I'm gonna have I'm gonna factor out the graded common factor between the first two terms. So it's x. So I have 4x plus 1, right? And the second two term, I'm gonna factor out the -2. So I have 4x plus 1 also. So you can see that we are having right now the 4x plus 1 and as a graded common factor between two term right now we are having. So I'm gonna factor out 4x plus 1, and then another factor gonna be x minus 2, right? And then you apply go to step number 4. You're gonna apply the zero probability, and you're gonna have apply the zero probability. I have 4x plus 1 equal to 0, or x minus 2 equal to 0, and you have x equal to, you know what, let's slow down a little bit. I'm gonna minus 1 both inside 1, and then I have plus 2 both inside, plus 2 both inside. So I have 4x equal to -1, and here's x equal to 2, and then I have x equal to -1 over 4, and I have x, so r equal to 2. So these two may be the solution, maybe. So what I have to do is I have to check the solution if it is satisfied. So check, let's say x equal to -1 4. Go to the original one. I have square root of 3 times -1 4 plus 3 equal to 2 times -1 4 minus 1. So then simplify, then I'm going to have the left side going to give you square root of 2.25, and the right hand side will give me -1.5. Okay. So this is so this is gonna give me 1.5 equal to -1.5. So that is not a good. That is not true. Not true. Not true statement. Not true. Okay. So x equal to -1 over 4 is not a solution. Let's check the other number. Say x equal to, oops, x equal to 2, and I have what? Square root of 3 times 2 plus 3 equal to 2 times 2 minus 1. And then that's equivalent with 3 times 2 equal to 6, 6 plus 3 equal to 9. So square root of 9 equal to 2 times 2 is 4 minus 1. And then that gives me 3 equal to 3. And that is true statement. So solution is x equal to 2. So, oops. Okay. Okay. That is good one. Oops. Let's see. Okay, so let's have another one. Have another one part of that have radical in both sides. Okay, so what I should do in this case? Let me see. So I don't know that. Okay. So note that radical in both hand side. Right. You see that we are having radical in no hand side. Right. So in this case, you can see that if you still follow follows 4 steps, you notice that in the right hand side right now we did isolate radical already, right? So I'm gonna right away square both hand side. Okay, so I'm gonna square both hand side, and I have x plus 1, I square it, and I have square 2x minus 1, I square it. So then now I can have if you apply the formula that's say a plus b, no, a minus b actually, a minus b square and equal to a square minus 2ab and plus b square. If you keep remember this one, you can know that you can apply that formula into the left hand side over here, and that's going to give you as square root of 2x square and minus 2a in here is square root of 2x, right? And b in here is 1, and then I will even add with b squared, which is 1 squared. That is for the first, the left hand side right now. For the right hand side, you are just having x plus 1 because the square root and square it just eliminate each other. Okay, so from here, if I want to simplify, let's see what I have. The left hand side now I have 2x minus 2 times square root 2x and plus 1, and that equal to x plus 1. Okay. Okay. The thing in here is I am still having a radical in one hand side. So I need to isolate this guy. I need to come back with the first step, which is isolate this guy, right? Isolate it. Okay. So how can I isolate? I'm gonna minus 2x and minus 1, both hand side. Okay, so minus 2x and minus 1 go inside. So I have um, so this guy is gone, this guy is gone, and I have negative 2 square root 2x equal to negative x, and 1 minus 1 is 0, right? Okay, so I'm going to divide by 2. Let me see. Is it any other way? No, actually, you know what? I will keep this negative 2 here, and I just gonna square both inside. Actually, I'm gonna multiply by negative 1 both inside to cancel this negative, right? So I have the left hand side gonna be 2 square root 2x equal to x, right? So for now, I mean, you can divide by 2 both inside to isolate 2x. But honestly, later on, because later on you will have to multiply by 2 back to term in order to not having denominator. So I would like to just square both inside, and for this case you can still square the 2 over here, so that's okay. So let's square both inside. Okay, so what does that mean? I actually trying to isolate the whole, no, the whole this, right? Whole this. Okay, so now I will have what? The left hand side give me 4. Let me go down this one. 4 times 2x, right? If you remember the power rule in exponent, and that's give me in the right hand side give me x squared. Okay, so this will give me the equation as ax equal to x squared. And if I subtract both inside by ax, I'm going to have x squared minus 8x equal to 0. And then I factor out the x. And I have x minus 8 equal to 0. So I can now apply the 0 factor properties to solve this problem. And it's give me x equals 0 or x minus 8 equals 0. So then I can have as x equals 0 or x equal to 8. So there may be the answer, but there may be the solution. So we need to check if x equal to 0 is a solution, and I have to plug it back to the original equation. So square root of 2 times 0 minus 1 equal to square root of 0 plus 1. And that's give me 0 minus 1. That will give me the left side become negative 1. The right hand side give me a square root of 1. It's 1. So this is not true. Not true. Not true statement. What about x? X equal to 8. That gives me square root of 2 times 8 minus 1 and equal to square root of 8 plus 1. And the left hand side now give me square root of 16 square root of 16 minus 1 equal to square root of 9. And they are this is a true statement. And the true, so then you can state that so solution is x equal to 8. Okay. Lastly, or maybe not lastly, actually, is the last example for solving radical solution that we have. One more with a cube root, right? What I'm gonna do is, in this case, actually, I didn't have the isolate step already, so I'm gonna skip the step number 1. I'm gonna just right away move to step number 2, which is doing, power rule, apply power rule in here. So I'm gonna I having cube root of 4x minus 7 equal to 4, right? And I'm gonna do the power 3 both inside, right? And I'm gonna have the left hand side become 4x plus 7. The right hand side become 4 to power 3. So what is that equal to? Use a calculator, and you will have 64. You minus 7 both hand side. Okay. And you will have 4x okay, 4x equal to where is it? Let me see. I make a mistake here. 4x minus 7. Why I put that? 4x minus 7. So this one is minus 7. Add 7 both inside. Okay, so 64 plus 7 is gonna be 71. And I'm gonna divide by 4 both inside. And that give me x equal to 7104. 7104. Is this a solution? I need to check, right? So check. X equal to 71/4. And that's me cube root of 4 times 71/4. And minus 7. Is it equal to 4? I know that's the left hand side become 71 minus 7. So it is 64 cube root equal to 4. And is that true? Yes, it is true statement. So solution is x equal to 71/4. That's really it. Okay. Okay, so we have a lot of example about solving a radical equation. So let's move to Pythagorean theorems. So as I state above, we will follow the formula as a squared plus b squared equal to c squared. Remember that in here c is a hypotenuse and a and b are legs. So let's do an example in here. Let's give me an FDTV has the white the width, right? The width of 60 inches and the height 32 inches. So So I have so as a picture here, right? 60 inches and 32 inches. And find the diagonal of the television. And why is it called 68-inch television? So in order to find the diagonal, what is the diagonal? Diagonal is use this is the line, the I mean the lines in the middle. No, I want to say that the line that divide the TV become like two triangles, right? Equal each other. So it is a red line that I have just show you, uh, and uh, and we're looking for it. So in here you see that we are having right now a right triangle with two legs. One is 32 and one is 60 inch, but we are looking for the hypotenuse. So so let's say so let's say A in here is 32, B in here equals 60, because these A and B are two legs, right? So I have from Pythagorean theorem, we have uh, and, and A equal to 32, B equal to 60. So A squared plus B squared equal to C squared. And that's how to I have 32 squared plus 60 squared equal to C squared. And then I'm gonna have what is 32 squared? I'm gonna be no, sorry. Let's make it easier. I have C, a square root both inside. C will be equal to square root of 32 squared plus 60 squared, like that. And then I have, so C equal to 68. So I'm going to simplify, right? Okay, so that is a way to apply the Pythagorean theorem on the real life problems. Okay, so now let's talk about the distance between 2 points. Okay, so actually, in order to find the distance between 2 points, we did apply the Pythagorean theorems and derive as to find the distance between 2 point formula in mathematics. And for example, in here we have like a a right triangle over here, and we are looking for and we are having like point A. No, actually, yeah, just saying like a point. The first point is x1, y1, and the second one is x2, y2. Um, so in order to find the distance in between these 2 points, we actually consider it as the hypotenuse of the right triangle. So we have to square root both inside for finding um, the distance between to this point. And so I have the formula as um, the distance of two points. And here that distance is non-negative, right? Okay, so d equal to square root of x 2 minus x1 square plus y2 minus 1 square. So let's use that to find the distance formula in between 2 points. Okay, so let's do an example over here. So say find the distance between the point -2, 3, and 1 and 4. Let's label. So here's x1, is y1, is x2, is y2, right? So the distance gonna be using a formula, right? So I have x1, x2 minus x1. X2 was 1 minus a -2, -2 square, and plus with y2 minus y1 square. So y2 was -4, and minus y1 was 3 square. And now let's simplify it. I have square root of 1 plus 2 gonna be 3 square, and then plus with a -7 square. So I will have 9 and then plus 49. 9 plus 49 gonna be 9 plus 49 gonna be 58. Let me see, make sure. So I have square root of 58. And if you use calculator, you will notice that this will give me 7.62. This is the distance of the 2 above. Okay. All right. So lastly, let's solving the equation xn equal to k. So for example, number 4 over here, I have x cubed equal to -64. How can I solve this one? So I'm gonna do cube root both inside. Okay. So remember that in here. Here I have note n equal to 3, which is a odd number, right? It is odd. So I'm gonna right away have I'm gonna have cube root what happened? Oops. Uh-oh. X cube equal to cube root of -64. So you will have the left hand side become x, the right hand side will become -4, because you know that -4 to the power 3 going to be -64, right? So okay, so that is the answer. So we have the second one, that n equal to 2 is even, right? So what I'm gonna do for this case, I square it both hand side, and I finally will have x become positive and negative of square root 12. So that's because n is 2 is even. Okay. Okay. So let me circle the answer. Okay. And okay. Now, lastly, so for the column that 2 times x minus 1 to the power 4 equal to 32. What I have to do is I have to isolate. This guy. I have to isolate the power 4. Okay, so let's see if I have note that for you guys. Yeah, I didn't, but anyway, for this column, you need to um, divide both inside by 2 in order to isolate the power. Right? In order to isolate the power 4, right? So I divide by 1 inside by 2. And I have x minus 1 in the left hand side, power 4 equal to 16. And now, in order to get rid of the power 4, I need to 4 root both inside. Right? 4 root both inside. 4 root, 4 root both inside. And I will have x minus 1 equal to 4 root of 16. So I'm going to have plus and minus. Remember that in here n equal to 4 is even, right? Plus and minus 4 root of 16. That's me x minus 1 equal to uh, 2 or x minus 1 oops, equal to minus, oh, come on, man. All right, minus 2. And you're going to have x equal to, you add both inside by, you add both inside by 1. And you're going to have x equal to 3 or x equal to -1. Okay, so that will give me the answer. This guy. Okay, so remember that for the equation in the form, in the power form, you don't really have to double check the solution. But for the radical form, yes, you have to check. You have to have step number 4. Okay, so so note that for in order to solve the power form equation, we don't have to check because, I mean, we don't have, but if you want, you can still do, okay? And check the solution. Check the valid solution. Or I can just, you don't have to do to check step 4, right? But in the
radical form. A radical function. No, no. Radical in the radical form equation. We must check step 4. Okay, so we're gonna stop this section 10.6 here, and we'll see you in section 10.7 later.